folks. Today we want to note some few things about differentiation and integration. So I will start with what we call kinematics. Kinematics are those movements of particles in motion. And a good thing about this is that for those who do physics, they have an upper hand because they know the formulas and they know how to calculate this. And maybe if I start, I will say if I take ds over dt, it gives me what you call velocity. Velocity, ds over dt, it gives me what you call velocity. Velocity. And if I take the second derivative of ds over dt, that is dv over dt, I get what you call acceleration. And as we know, at minimum, not at minimum, but at maximum velocity, acceleration is always equal to what we call zero. Acceleration is what we call zero. And when we're talking about a particle being momentarily at rest, velocity is always equal to zero. But the best thing about this is that when velocity is equal to zero, time is increasing because the particle is resting, but the time is continue moving. Now, maybe another thing that if I take dy over dx, I get the gradient of the curve. And as we know, the gradient of the curve, now grad of the curve is the same as gradient of the tangent. Gradient of the tangent is the same as the gradient of the tangent. And we know this that at normal, so at normal, m1 multiplied by m2 must give you -1. This means that if I take the gradient of the tangent, which also equals to the gradient of the curve, I multiply by the gradient of the normal, I get what you call -1. So the product of the two, the normal and the tangent, gives me what you call -1. Another thing that you're supposed to know that is that when a particle, when the gradient is positive, the curve is at minimum. This means that the turning points of that graph will be minimum, and when the vice versa is always true, which means that when the gradient is negative, the curve